Welcome back to my YouTube channel. If you are just joining this community and you haven't yet subscribed to my channel, do well to click on the subscribe button and also share my video lessons with your friends because it will help you all improve greatly in chemistry. As you can see on the board, in the course of this video lesson, I'll be explaining on the topic in chemistry called stoichiometry, specifically focusing on what we call limiting and excess reagent. Meanwhile, this question I'm about solving on the board is not on limiting and excess reagent, is on normal stoichiometry practice question, because you have to remember how this is done before we go over solving questions on limiting and excess reagent. I have to do a quick recap and tell you guys the difference between solving questions on normal stoichiometry and also solving questions relating to stoichiometry of limiting and excess reagents. So you have to watch closely. If you've not yet subscribed to this channel, do well to hit on the subscribe button and also share these lessons with your friends. Meanwhile, this aspect of chemistry is very important for those preparing to write the post-UTME examination for any Nigerian university and even the JAMB examination. So watch closely as I explain this particular aspect of chemistry. So let's solve this first practice question together. And the question says, determine the mass of sulfur 4 oxide. What I saw here is determine the mass of sulfur 4 oxide. And you already know that sulfur 4 oxide, the way it is written chemically is SO2, obtained when 9 grams of oxygen gas react completely with sulfur according to the equation below. This particular practice question is very easy. I'm going to explain in a very easy to understand pattern so you can understand this aspect of chemistry because it is very easy. So first of all, they are asking us determine the mass of sulfur 4 oxide. Determine the mass of SO2. So we are looking for the mass of SO2. First of all, since this particular aspect of chemistry is stoichiometry, you already know that you'll be needing a reaction. In some other cases, some other exam conditions, they might not give us the equation of the reaction. But you understanding this question, you can write out the equation. It is easy. I had to bring out the equation for us so that that aspect will not be tough. It's actually easy. Let's work it together. The question says, determine the mass of sulfur 4 oxide. Even if this equation was not here, I already know what they're asking us to do, and I already know the equation to write. They asked us, determine the mass of sulfur 4 oxide, which is SO2, obtained. So sulfur 4 oxide was what we got at the product, because a reaction is made, it has two sides. We have the product side, which is the right hand side of a reaction, and also we have the reactant side, which is the left hand side of a reaction. So they're not asking us, determine the mass of sulfur 4 oxide, this sulfur 4 oxide obtained. So I already know that, okay, sulfur 4 oxide was obtained, SO2 was obtained. SO2 is my product side when 9 grams. So how did they now obtain SO2? When 9 grams of oxygen react completely with sulfur. So this will tell me that oxygen and sulfur reacted to form SO2, which is sulfur 4 oxide. I believe you are following me. That's how they got this reaction. So moving further, another thing you must watch out for in this topic, stoichiometry, be it normal stoichiometric practice question, be it stoichiometric practice question dealing with limiting and excess reagent, what you must watch out for is that before solving, your equation must be balanced. So we have to watch and check this particular equation if it is balanced. But from the look of things, this equation is already balanced. Okay, let's check together. How many sulfur do we have in the left? We have one sulfur. I can just see one sulfur. In the right hand side, I can also see one sulfur. So sulfur is balanced. Oxygen, I'm having two oxygen, two atoms of oxygen. In the right hand side, I'm having two atoms of oxygen as well. So oxygen is balanced. So in general, this equation is balanced. So let's progress. How do we now get the mass of sulfur dioxide? Now let me explain something to us. In the aspect of chemistry, stoichiometry, it is all about relationship. And how many things are we relating? We are relating just two parameters. Listen carefully. Stoichiometry is all about what? Relationship. Please note this. And how many things are you relating? Two parameters, not three, not four, not one, not 10. You are relating just two parameters together to get your answer. It is actually very easy. So let's read our question to know exactly what we are relating. To know what we are relating is dependent on what is given in the question. And after explaining this practice question, I will now give us some tips on how to tackle this aspect of chemistry which deals with limiting and excess reagent. Please watch, and how you can actually know questions that is on limiting and excess reagent. Please watch. Okay, so moving further, they asked, determine the mass of sulfur oxide. Wow, they are asking me to get the mass of sulfur oxide, which is SO2. I've brought out one of the parameters we are relating. Because I said we are relating how many parameters? Two. After getting the parameter you are relating, you bring them down. I will explain. I already have a full video lesson under this aspect of chemistry called stoichiometry. So if you are finding this aspect difficult, but I believe after this video lesson, you get to understand the rudiment, go watch that particular video lesson on my YouTube channel. It is very, very important. Okay, the link will be up here. But do well to watch this video first before you go over to that particular video lesson. Okay, so let's progress. Determine the mass of sulfur oxide, which is here, obtained when 9 grams of oxygen. I saw this again. This is a very, very important parameter. 9 grams is a parameter. Okay, 9 grams of oxygen. Okay, so I had oxygen, 9 grams of oxygen, or oxygen gas rather, reacts completely with sulfur. Okay, they told us that 9 grams of oxygen reacted completely with sulfur to get SO2. That's what the question is all about. So at the end of everything, how many parameters have I related? 2. You can see what I said. Stoichiometry is all about relationship. This is how you solve any practice question under this topic, which is stoichiometry. Okay, before we now go over to those of limiting and excess reagent, and now I will tell you what to do. So next thing we've brought out, we've highlighted what the two things we are relating, we'll bring them down. Okay, so you bring them down. Make sure your equation is balanced. And from the look of things, this equation is what? Balanced. So let us bring the two parameters down or rewrite them. It is between oxygen and SO2. So oxygen O2 to give me SO2. Are you getting the point? So I brought out the two parameters we are relating to solve this question, and it is very, very easy. Now, please note this. Before I progress to continue solving this question, we have to note this. For practice question on limiting and excess reagent, when I get there, I will explain it from the scratch. But it is important for me to tell you this. For limiting and excess reagent type of question, how do you know that, okay, this particular question is on limiting and excess reagent and this is what I'm supposed to do to solve it? You will, or in the question, they will give you two parameters for your reactants, because limiting and excess reagents can also be regarded to be called limiting and excess reactants. Do you understand my point? So it is actually limiting. The word limiting reagents can also be called limiting reactant. Remember, your reactant is in the left. Okay, these two guys are my reactants. Are you following me now? So limiting reagent is also called limiting reactant. Excess reagent is also called excess reactant. Are you following me now? So how do you now know that, okay, a question is on limiting an excess reagent or limiting an excess reactant? You can use them interchangeably. How do you know? They will give you the parameters for both reactant, and they will still be asking you to get something, or they will still be asking you to get the mass of your product formed. Are you following me now? Because in this question, they're asking us to get the mass of SO2 formed, obtained, which is my product. Are you following me now? Please watch, listen carefully. They'll give you parameters, values for your reactant, both of them. Okay, you now determine which one is limiting. I've not said this before. I'm saying it now. You will now determine between those two reactants which of them is limiting, for you to now pick it to get whatever you're looking in your product side. Are you following me? I repeat, they will give you parameters for both of your reactants. In this particular question, they gave me just one parameter for my reactant and they gave me for oxygen. That is why I brought it out to get what I'm looking for, which is my product side, SO2. In my video on stoichiometry, I've explained this many times. Are you following me? So I'm going to say something. Let's say this question is on limiting an excess reagent. It's going to be in this format. Obtained when 9 grams of oxygen gas react completely with, for example, this is not the question, react completely with, let's say, 6 grams of sulfur. React completely with what? 6 grams of sulfur. So if you now observe, they now, in this particular question, they gave us parameter for both oxygen and they gave me parameter for both what? Sulfur. So when I see this, I will say, okay, this particular question is on limiting an excess reagent or limiting an excess reactant. What do I do? That's the question you ask yourself, and that's what I will clear after solving this particular practice question. I'm going to give us another practice question specifically on limiting an excess reagent or reactant. Are you following me now? But in this particular question I'm solving, it is on the normal stoichiometry practice question. So guys, moving further, let us solve this question the way it is. Simple. How do you solve your stoichiometry practice questions? Very easy. First of all, after highlighting the two things you are interested in, you bring them down from my video lessons you've watched, okay, on stoichiometry is the one I've done before. So then, you then write out their mole ratios. The mole ratios according to what you are seeing standing in front of the elements or compound. Because this is an element, this is a compound. Or you can call this a molecule as well. So the numbers of the moles standing in front, whenever you are not seeing anything standing in front of it, be it an element or a compound or a molecule, you take it to be 1. I believe you understand that. So we are having 1 moles here invisibly. Okay, 1 mole as well. So you now bring out if there was 2, you write your 2 here. If there was 2 or 1 million, 3, 4, 5, any number, you bring it down. So first thing first, you bring out your moles. 1 moles of oxygen to give me how many moles of SO2? 1 moles of SO2. This is why am I doing this? Because this to have more understanding about chemistry calculations and solving all of this type of questions. I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen. How it was written in the particular question. Are you following me now? So after you do that, you then go back to your question and see the parameter given, because if you observe, we are looking for the mass of SO2. We are looking for this guy, mass of SO2. But since here we've written 1 mole, 1 mole, the down part, because first of all, your up part should be written as a result of what you are having standing in front of the element or compound. Okay, and we've written it 1 moles, 1 moles. So now give me here down should still be in moles. Your unit should not change. Because if it change, it will change the way your answer will be, and it's not going to be correct. So here will now be X moles of SO2. Okay, X moles of SO2. So what are we writing here? There should be a value here. The value that should be here is the number they gave us for our the element, which is oxygen. And what was it? It was 9 grams of oxygen. So simple conversion. So what are we trying to do now? We are trying to convert 9 grams of oxygen to moles. So guys, how do we convert 9 grams of oxygen to moles? Simple formula to be applied. In that particular video lesson, I wrote out first the 5 important formulas under this topic, stoichiometry. I wrote out all the formulas, and I'm going to put the formulas here on the screen so you look at it, okay? And out of these 5 formulas written here on the screen, you can see I'm using number 1, the first. Now, let me explain something for you. Here is the first formula. The formula is this: number of moles, which is N. This what N mean? Number of moles is equal to mass divided by molar mass. Please watch. Please, let's be specific, because the question said 9 grams of oxygen gas. They did not say 9 grams of oxygen. Please note, oxygen gas, you have to be specific, because oxygen gas is symbolized as O2. Do you understand? They did not say oxygen atom, that is just O. Oxygen gas, that's what the question said. That's why we have to write that back. Oxygen gas is O2. Note that. So, for we to convert 9 grams to moles, I have to use the first formula. Why? Because 9 grams is mass. Are you following me now? You know, in the other formula, you can see the other formula, which is number of moles is equal to concentration times volume over 1,000. I can't use that because we were not giving concentration for oxygen. We are not giving volume of oxygen to convert to moles. I don't know if you are following my point. Because I saw 9 grams, I know that, okay, that is mass. So definitely, the formula you use should have mass in it. And that's the first formula, which is number of moles is equal to mass over molar mass. So then, what are we looking for? We are looking for number of moles. We want to convert 9 grams of oxygen gas to number of moles. Simple. It's going to be number of moles now be equal to what's the mass of oxygen gas? 9 grams divided by molar mass of oxygen gas. Remember, oxygen gas is what? O2. Okay, simple now. I believe you understand this already. Remember, the atomic mass of sulfur is 32. The atomic mass of oxygen is 16. This is something you should know. So, atomic mass of oxygen, we have to calculate molar mass now. The atomic mass of oxygen is 16. But we have 2 atoms of oxygen. So, it's going to be 16 times 2, which equals what? 32 grams per mole. Hope you are following me. 32 grams per mole. So, here becomes 32 grams per mole. So then gram cancel gram. So what becomes number of moles when we hit our calculator? Number of moles now becomes 9 divided by 32. That's 0.28125. Okay, 0.28125 moles. So this is the number of moles of oxygen that should be written here. I believe you are following me. So here should be 0.28125 moles. Are you following me? So cross multiply to look for X, which, because remember they asked us to get the mass of sulfur oxide. So X will not be equal, so X moles will not be equal to simple cross multiply where this will times this. Hope you know, and divide by 1. Hope you know this. So it's going to be 0.28125 moles times 1 moles divided by 1 moles. Hope you are following me. So it's going to be, okay, you already know what it is. So here becomes 0.28125 moles of which guy now? SO2. Because we are looking for SO2. Hope you are following me. It's actually very easy. Okay, guys, moving further, what next do we do? We've gotten the numbers of moles of SO2 according to what we've explained so far. But the question, what are they asking us to get? Is it not mass of SO2? Yes, it is mass. So how do we now convert this mole value we've gotten back to mass for SO2 according to the question? We use same formula. You know, I gave us 5 of these formulas. It's on the screen, but we use this one because it deals with mass. In some other cases, you know when to use the concentration, you know when to use others. It's just about you being consistent, practice questions before you now get to understand which formulas to use any single time. Are you following me now? So in this case, we have to use this formula back, which is number of moles again is equal to mass divided by molar mass. So what are we looking for? We are looking for mass. So we'll make mass subject. Mass will now be equal to numbers of moles times molar mass, yeah, divided by 1. Hope you're following me. Simple. Now, first of all, let's calculate the molar mass because we've got a number of moles already, which is this. Let's calculate molar mass of SO2. Simple. This is SO2. Okay, it's a compound. So let's get our molar mass. Simple. Okay, molar mass of SO2 is going to be, what's the atomic mass of sulfur? According to what's written here, 32, you plus after writing one, you plus. What's the atomic mass of oxygen? 16. Are you following me now? And how many atoms of oxygen do we have? 2. So it's going to be 16 times 2. So what becomes the molar mass? It's going to be, I think 64, yeah. Because here is 32, here is 32. So it's going to be 64 grams per mole. Okay, so what becomes the mass? So mass will now be equal to number of moles, which is this value, 0.28. Okay, let's write it here. So let's write it here. Mass will now be equal to mass of SO2 is going to be equal to, what's the number of moles? That value, 0.28125 times, what's the molar mass? 64 divided by 1. Anything divided by 1 is that particular thing. So let's solve. So we're going to be 0.28125 times 64, which is molar mass of SO2 divided by 1. So we're having a mass of SO2 to be 18 grams. Are you following me now? So this is the answer to this question. Okay, the reason why I took my time to solve this question is because I want you to understand the rudiments of stoichiometry before we go back to solving questions on limiting and excess reagent, and it's very easy. So let's solve a practice question on limiting and excess reagent. Okay guys, let's get into the next practice question, and this particular question is on limiting and excess reactant or reagents. Now, first of all, we have to know what limiting reagents are, and also we have to know what excess reagents are. From the word limiting, it means that, okay, first of all, let us say A reacted with B to give us C, for instance. Are you following me now? So what I'm talking about now is limiting and excess reactants or reagents. They can be used interchangeably. So you already know that my left hand side of a reaction is the reactant side, whereby my right hand side is my product side. Are you following me now? So we are focused now on the reactant. Reactant now can be either limiting or excess. Are you following me now? So we have two reactants here. One of them will be the limiting, while one will be the excess. From the word limiting, for these two guys, A and B, these two substances will react together completely. If both of them react together and both of them were completely used up at the same time, it will give rise to the formation of product C. Are you following me now? But let's say, for instance, both A and B were reacting together and one of them finishes first in the reaction before one. What do we call that one that finished first? Are we to call that one that finished first limiting or excess? Simple. Because A and B reacted together and between A and B, one of them finishes first in the reaction. So let me quickly say this. If one finishes first, the reaction will not go into completion. Are you following me now? So the point I'm trying to say here is this. The reactant that finishes first in a reaction should be called the limiting reactant or the limiting reagent, because it finishes first before the reaction went into completion. So that reaction there'll be a stop to that reaction. Do you understand? There will be a stop to that reaction. So let's say A finishes first. So A will become the limiting reactant. Are you following me now? Whereby automatically some part of B will be remaining because B had not finished before A finished. Do you understand? So B will become the excess, okay? The excess reactant. Are you following my point? So that's what this concept of limiting an excess reagent is all about in this aspect called stoichiometry, and it's still all about reactions. Understanding reactions here is very, very important. So we have to break it little by little. Are you following me now? So that's what I'm trying to say. The one that finishes first in a reaction, both must be found in the left. So in this context of this question, which will be my limiting excess reagent is going to be between this compound or this compound because they were in my reactant side. Hope you are following. So that's how this particular aspect works. So let's get into solving this particular practice question. Now let's read the question together, and the question says the explosive TNT trinitrotoluene is made from toluene. Remember, toluene is a benzene derivative. Remember, benzene is an aromatic compound. Do you understand? And this is the chemical formula of toluene. So get the chemical formula of toluene is very easy. It's not hard. I'm going to still explain that. And nitric acid. So it's formed from toluene and nitric acid. For we to get TNT, which is used as an explosive, which is a benzene derivative as well, is gotten from toluene itself, combining with nitric acid, which is HNO3. Remember, nitric acid is popularly called or formerly called aqua fortis. The equation for the reaction is this below. Okay, this is toluene. Toluene is a benzene ring or a benzene structure that is combined with a methyl group. Methyl group is CH3. Remember, at every junction there is carbon. At every junction of this benzene structure, there is carbon bonded to hydrogen, bonded to hydrogen, bonded to hydrogen, and bonded to hydrogen. So if we now calculate the carbon hydrogen arrangement, it will give us C7H8. Let's do that. So it's going to be C is between C and H now, okay, because it's carbon and hydrogen I can see here. So how many carbons do we have? Let's count the ones here. 1, 2, 3, 4, 5, 6. I start from here, so it's 1, 2, 3, 4, 5, 6. Okay, I can't put 6 because there's one carbon here. So it's going to be 6. It's going to be 7, right? So it's going to be C7H8. I don't know. Let's count if it's 8. So here is 3 already. Here is 4, 5, 6, 7, 8. Correct. Okay, C7H8. So this is toluene. Okay, that's what they told us. This is toluene. I believe you are following me now. They now said that both of them reacted to give rise to this TNT trinitrotoluene plus H2O. So let's solve the question together. So moving further, what do we do? Remember, in the first practice question I solved, I explained something to you to know questions that are on limiting excess reagent and to just know what to do. You don't have to waste your time. For limiting excess reagent, they'll give us the parameters for both of the reactants. But for normal stoichiometry question, they'll just give you for one of the reactant in relation to whatever you are looking for. I believe you are following me now. But for limiting excess reagent, they'll give us two parameters in the reactant side in relation to what we are looking for. This is what I mean. Tina said that when 100 grams, please follow, 100 grams of toluene, which is C7H8, and okay, let's watch, and 150 grams of aqua fortis HNO3 are mixed together. We mix them together now. Calculate the mass of TNT form. Calculate the mass of trinitrotoluene form when we mix both of them together. Remember, in that particular question, I think they gave us just one mass, which is 9 grams of oxygen. Do you understand? This was not given, so you already know that, okay, this is a normal stoichiometry practice question. So this is what they gave to me. For instance, is that 9 grams of oxygen, and they asked me to get something for the product SO2. I brought them out, down, and get my answer. But now they gave us two parameters. They gave us both for this guy 150, okay, for this guy is 100 gram, whereby for HN3 is 150 gram. So what do we do? Can I just pick one and solve, look for my product? Because I know that if you already know what to use to solve, if you already know what to do, the particular reactor to use to relate to what you are looking for, which is in your product side, that will not be a problem. It's to determine what to use. So basically here, you must note this. It is your limiting reagent or your limiting reactant you use to get whatever you are looking for in that particular practice question. So first of all, we have two of these reactants here. So which one am I to use? Is it my limiting or excess? Limiting. So let us determine the limiting together. That's why you have to know how to determine your limiting reagent or reactant before you now solve. Don't just assume any of them to be the limiting. I know some persons will now say, okay, C7H8, which is toluene, and HNO3, which is nitric acid or aqua fortis or triazonitrate 5 acid, looking at their masses, for toluene it is 100 gram. For this one, HNO3 is 150 gram. So limiting is what that finishes first, right? So, okay, 100 will finish first before 150. Please don't do that. Okay, don't do that. You might not get it right. Doesn't work always. That is why you have to know how it is done. I'm going to explain it detailedly in the way that you'll be able to understand. So watch closely. And if you've not yet subscribed to my channel, do well to click on the subscribe button and also share this lesson specifically with your friends because it will help you all. So let us progress. So first of all, my step here is to convert this particular value to numbers of moles. That's my advice, so that you don't have stress when solving. So I want to convert 100 gram of toluene to a number of mole. It will help us. So, and I'm going to do same for this. And you already know to convert grams to mole. You already know the formula now. That first formula we always use is the very popular formula. Number of moles is equal to mass divided by molar mass. Okay. So basically here, let's quickly calculate the molar masses of both of the compound because we use it. C7H8, okay? Molar mass, mm, is going to be, carbon atomic mass is 12, okay? And we have hydrogen here. Hydrogen is 1. There's hydrogen here. We're already written 1. Nitrogen is 14. Hope you know that. And oxygen is 16. So it's not hard us to get our molar masses. So let's calculate molar mass of toluene first. So C7 is going to be 12 times 7. Hope you know this. This is very easy. Plus hydrogen atomic mass 1. Okay, it's going to be 1. And we have 8 of hydrogen here. 1 times 8. So molar mass is going to be equal to 12 times 7, 84. Okay, 84 plus 8. So this is 92 grams per mole. Hope you are following me. That's the molar mass of the compound. Toluene. What about HNO3? Very popular, is 63, but let's calculate it together. So HNO3, so it's going to be molar mass is going to be equal to, what's the hydrogen is 1 plus, you know, it's plus, not minus, not divide, not times. 1 plus nitrogen is 14 plus oxygen is what? 16 times 3. So 1 plus, that's 15 plus 16 times 3, that's 48. So molar mass mm is going to be equal to 15 plus 48. That's 63. Yeah, we already said that initially. 63 grams per mole. So this is the molar mass of the compound. So it's not hard us when solving. So let us calculate the number of moles for each of them. Same thing we have to use here. Number of moles, same formula, is equal to mass divided by molar mass. Okay. So what's the mass? What's the mass? The mass is 100 grams. Okay. Divided by the molar mass of the compound, 92 grams per mole. First of all, the step you must follow, if the values were in masses, as you are seeing here, convert them to moles. If they were in moles, leave them like that, and focus. After doing this, you now follow the next step I'll tell you to do. Okay, if they're in moles, already, just hold on and wait until I get to the next step so you follow me. Okay, now listen carefully to this. Okay, the parameters they'll give to you, the values of these guys is not always in mass, in grams rather. Sorry, it's not always in grams. It can be in moles or volume. Okay, all that matters, you must convert them to numbers of moles, which is n. Do you understand? Do you understand what I'm trying to say? You must make sure that they are in that smallest unit, which is moles. Because you know that moles is like the smallest unit of all of these things we are doing here, moles. Like how a cell is the smallest unit of life. Like how the nephron is the smallest unit of the kidney. Without the nephron, the kidney cannot perform well to its full potential, because the nephron is the basic structural and functional unit of what? The kidney. So that's what we're trying to say. You must make sure that everything is in moles so you can solve very well. So moving further, same step. Number of moles equals to mass, which is 150 grams divided by molar mass, which is 63 grams per mole. So what are we to do? Convert them. So it's going to be 100 divided by 92, which is, I'm having 1.087 moles, okay, whereby 150, okay, divided by 63, that's 2.3081 moles. Yeah, I've gotten it already. So my point here is this: please don't make this mistake by saying that, okay, I'm trying to get my limiting excess. I know that is the limiting I'll use to relate to my product. So then, where am I wasting my time? Yes, 100, where's 150? 100 is smaller than 150. So if they were to react together to form this will finish first. Don't do that. Okay, you have to follow the step I'm teaching you now to get your answer without stress. Okay, so that's for that. So you can see that we've gotten the number of moles of both of them. Okay, both of the parameter, we converted them from that mass they are in to moles. So the next step, please follow. The next step is this: you rewrite the way it is. Both of them were written in the reactant side of this equation. You write them down in each side. Just follow me. Okay, here is C7. I'm trying to manage the board so it can contain everywhere. C7H8 to give me the way it is written, 3HNO3. Okay, if here was any number, write it the way it's written. No, don't change anything. So same applies. This same thing, put it here. C7H8 to give me 3HNO3. Okay, now listen carefully what I'm about saying. It is very important because the step I'm in now is very critical. This is where we determine which of the reactants or which of the reagents is actually limiting or excess. But at the end of getting which one is limiting or excess, it is the limiting we use to get whatever we are looking for according to the question. Okay, so how do we get the limiting or excess reagent? Very easy. Now, let's watch out for something. Now, if you observe, how many moles of C7H8 toluene were we given? Like, according to the equation, you know, if they gave you a equation that there's nothing standing in front of that particular element or compound, you just take it to be one now, invisible one. I believe you know this. So let's write our mole ratio. 1 moles to give me how many moles? I wanted to write E still the same as MOL or MOLE. To give me how many moles? 3 moles. If here was 1 million, put 1 million moles here. Are you following my point? So I've done something like this here. You do the same thing because it's same reaction. We are trying to determine which one is limiting or excess. Okay, please follow me. It is very easy. Whenever you see any question on this is the step you follow. I'm taking it slowly so that you catch everything. Okay, so that when you are giving practice question, you can actually solve it without stress. And if you are finding my video lessons helpful, make sure you subscribe to my channel, share these lessons with your friends. It will help you all. So moving further, let's focus on one of them now. Let's just focus on one before I get over to this part to determine which one will be limiting or excess. It's very easy. Since I am in the part of C7H8, since I'm in the part of toluene, I'll make toluene X. Are you following me? Am I not in the part of toluene? I'll make it what? X. Please follow. It's simple. X moles of toluene to give me how many moles of HNO3? The number of HNO3 we got here, is it not this? 2.381. Yeah, this is what we got. Okay, this is what we got. So I'll do that and then cross multiply. Are you following me? Okay, let's walk towards here. So you follow me. It's not hard. 1 moles, 3 moles. What column am I in? It's not HNO3 part. Yes, I'm in HNO3. So then I'll make HNO3X. And then for C7H8, I'll go and look for the number, which is this. 1.087 moles. And then cross multiply. So I'm looking for X moles of this guy. Now, what am I trying to do? Watch. Let's focus on this only first. Listen, no, let's focus on this. At the end of solving for x, at the end of looking for x moles of toluene, because what I'm trying to do now is to determine which of them is limiting or excess. Because at the start of this reaction, we were given 100 grams of toluene, which is equivalent to 1.087 moles of toluene. They are the same thing. Do you understand? They are the same thing. Just that they are expressed in different units. 100 grams of this, same as this, of toluene. So the point I'm trying to make here is this. We are trying to check which one is limiting or excess by doing this thing I just explained. So after me solving now, and the answer I get, listen, I want to make everything in respect to this. Because now we are working with mole. I don't want to put mass here now, but they are the same. So everything should be in respect to this. So after I solve, and then I see that the answer I get for toluene, because this was what we were given to power this reaction for toluene. This was the amount they gave us for toluene. Do you understand? Or this was the money they gave us to buy toluene. So we now, listen, oh, I'm just trying to use many illustrations so you get it. So this was what they gave us for toluene. That, okay, take, this is toluene. This is what I have for toluene already. But we don't know exactly what we need of toluene to power this reaction to get this. That's what we are trying to get. Find. So now if toluene is excess or if toluene is limited, so that we can ask for more toluene. Do you understand my point? So I'm trying to say here is this. If now the answer we get for toluene, I'm just trying to tell you the evaluation of everything so we'll know what to do. If the answer we now get for toluene is greater than this, what would this tell you? Let's say now we now have toluene to be 3, for instance, 3 moles, for instance, after solving. So it means that we have toluene to be what? 3 moles. So the toluene they gave to us here, was it in excess or limited? If, for instance, we have here to be 3 mole, we've not solved though, we have here to be 3 mole. Toluene they gave to us, is it in excess or it's limited? Please tell me. Okay, let me know that word. If here was 3, you already know it's higher than this. So that means toluene they gave to us was not enough. It was limited. So toluene will now be limited reagent, or limiting reagent rather. But if toluene we now got is smaller than this, what would this tell you? I mean, okay, toluene was in excess, so it's just little toluene we needed to power this reaction. They gave us more of this. So toluene is excess if toluene is smaller. Are you following me? This is something very important. So let's leave that part. Same applies to this. Let's say we got here to be higher. The same illustration. Let's say we got here to be lower. The same illustration. Are you following me? So let's solve. So it's going to be 1 times 2.381 divided by 3. So x moles, hope you are seeing the board, is going to be 2.381 divided by 3. That is 0.794 moles. Wow. So we actually need 0.794 moles of toluene to power this reaction into completion. So that means toluene they gave to us, this toluene is excess. They gave us too much toluene. So toluene, okay, let's leave that. So, okay, my own evaluation is that toluene is excess, but let's check for this. Let's check for this now. Do you understand? I cannot just conclude, but let's check. But if we got in one, I already know the fate of the other. Let's check for this. So x mole will now be equal to 1.087 times 3 over 1. 1.087 times 3 over 1 is same thing. Okay, we are having 3.261 moles of HNO3. Let me be specific, of C7H8, which is toluene. Now the point here is this. You can say I solved. The value I got for HNO3 needed to power this reaction into completion is greater than the initial they gave to us. It's 3 point something, and they gave us 2.8. That means, what would this tell you? Is this value, is it okay for this reaction to be powered? No. This is limited. This HNO3 is limited. It's not enough for us to power this reaction. Are you following my point? So it is limiting reagent. Yes. So this will tell us that toluene is the excess reagent or reactant, whereby HNO3 is the limiting reagent or reactant. Hope you understand. It's simple. Do you understand? I've explained it already. Watch this video again and again, but I believe you following me, you can actually get it once without stress, okay? So that is how it works. So guys, moving further, what do we do? Remember I said that it is the limiting reagent we use to get whatever we are looking for. And the question now says, calculate the mass of TNT. They're asking us to get the mass of TNT. Very easy. What do? We use the parameter for limiting reagent. Listen and listen good. It is not this evaluation I did to know which one is limiting or excess that I use to get whatever I'm looking for. It is the initial they gave to us. This one I just did is to determine which to use, is to determine which is limiting and excess, so I know exactly which of the compound to use to relate with whatever we are looking for. That's why I did all of these things. So it is not these answers we got that you now use to relate. I know I'm saying this. It is still your initial. Okay, if it was this, we use this number to relate with this. I believe you understand what I'm saying. I'm going to explain to you. Just watch. Okay, just watch. Let me just wipe the board. Okay, it is not all of this I did just now. This one I just did to tell you which one is limiting and excess. It is this guy or this guy. If this guy were to be the limiting, I'll use to relate with my product. So this is what I mean now. Just watch. Simple like A, B, C, D. So let's watch. So now we already know that, okay, the equation is balanced already. Okay, you must watch if your equation is balanced. The equation is balanced already. So the point I'm trying to make here is this. So since this is my limiting reagent, I'm going to relate. I'm looking for the mass. This TNT. This is the TNT, trinitrotoluene, reacting toluene and HM3. You get TNT. This TNT. Are you following me? This TNT. So I'm relating HNO3. Why? It is my limiting reagent with this compound, which is what I'm looking for. Okay, I'm relating both of them together. So that's how it works. Hope you understand what I'm saying. So then I'm going to use the same 150 grams. And we already converted 150 grams to moles, and this is what we got. Remember how we normally solve our number of moles, all those getting whatever we're looking for. Simple. Since I have business with this, I don't have business with this anymore. I'm going to wipe it off. Okay, and what I'm looking for. And it's going to be between HNO3 and the toluene. Write it the way it's written. 3HNO3 to give me C7H5NO2 close bracket 3. Okay, simple like ABCD. So what do we do next? Okay, don't confuse this part. Okay, it's like this. So have more understanding about chemistry calculations and solving all of these type of questions. I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen. So, all right. First of all, your 3 moles, your mole ratio should be written 3 moles to give me, there is nothing here, so it's 1 moles of this compound. Remember, we're looking for the mass of this. We are looking for the mass of this, okay? And we know the moles already of this according to the 150. I said you must use that one, no, not the one we solved for. So it's going to be 2.381 moles to give me X moles. Cross multiply, what become X mole class is going to be 2.381 times 1 divided by 3. Okay, what's that? Hope you understand now. So it's going to be 2.381 times 1 divided by 3. That is 0.794 moles of this compound, which is TNT. Are you following me now? But what are they asking us? They are asking us to get the mass. So for we to get, we've gotten the moles of TNT. For we to get the mass, you must know your molar mass. Very easy. So let us carefully solve for the molar mass of TNT. Simple. Just watch. Sorry for wiping the board this way. But I believe you're understanding the point so that we'll get it. So for we to get the number, for we to get the mass of TNT, we have to get molar mass. So this TNT again, let's rewrite it. C7H5NO2 open bracket, close bracket 3. Okay, so there's a way I want us to get the molar mass. Simple. Let's restructure this compound so it not be hard for us to get molar mass. So this is what I want to do. C7H5, 3 is outside the bracket, means that it's affecting everything inside the bracket. So here is an invisible one. So 1 times that 3 is going to be N3. And there is 2 here. 2 times 3, that's 6. It's going to be O6. So let's solve together. So we already know the atomic masses of each of them. So then carbon is 12. 12 times 7 plus hydrogen is 1. 1 times 5 plus nitrogen is 14. 14 times 3 plus oxygen is 16. 16 times 6. So let's press our calculator together. So it's going to be 12 times 7 plus 1 times 5 plus 14 times 3 plus 16 times 3. 16 times 6 rather, that's 227. I'm having 227 grams per mole to be the molar mass of the compound. So definitely, you already know that to get the number of moles, it's going to be, so get the mass, number of moles equals to mass over what? Molar mass. So what becomes number of moles? Number of moles now be equal to, what becomes the mass which we are looking for? So mass will now be equal to number of moles times this over 1. Okay, you know that number of moles times molar mass divided by 1. So what's the number of moles? This value is 0.794 times what's the molar mass? 227. Yeah, 227 grams per mole divided by 1. So what becomes our mass? So it's going to be 0.794 times 227. Okay, that's 180.3, no, 0.24. Yeah, okay, mass now be equal to 180.24 grams of TNT, which is trinitrotoluene, which is this. Do you understand? So this is the mass of the compound. Very, very easy without stress. So I believe you understand how all of this concept works. I will give you your own practice question so you carefully solve and provide the answer in the comment section. All right, guys. So before I give you your own practice question, I have to say this is very important on stoichiometry of limiting and excess reagent. It's actually very, very important. Now, let's understand something. In some other cases, you'll be seeing they will ask you questions on, you will see that, okay, it is on limited and excess reagent, but what they will be asking you is this. Calculate the theoretical yield, calculate the percentage yield. Very easy. Let me explain something. This theoretical yield is like the mass of the product formed at the end of both reactants mixing together. Do you understand? So this is my major product. This is also a product, but this is the major product. So the mass of this, they will not, what's the theoretical yield? You know that, okay, this guy there, because between this is major. Do you understand? So theoretical yield has to do with the mass of your product formed at the end of your reactant, two of the reactants coming together and mixing to form the product. So theoretical yield is what we've calculated already, which is this 180 grams, 0.24 grams. Are you following me? This is my theoretical yield. But you'll not be surprised. Then I wrote, and I changed the format of the question, 122.5 grams is obtained. Actually, is obtained of like 122 or 122.5 grams of TNT is obtained. This one, that's how the question comes. Please watch. They will not tell you that, okay, they obtained 122.5 grams when they mixed. But they now ask you to get the theoretical yield. Theoretical yield is like calculated yield. Is what you are calculating for. This is what they got about. This is your own you got. This is your own theoretical yield. It's like calculated yield. Because them asking to get theoretical yield, if they ask to get your theoretical yield, definitely they will ask to get your percentage yield. And how do you get your percentage yield? Remember, percentage is like this symbol. So percentage yield has its own formula, which is this: actual yield divided by the theoretical yield. You know, this percentage, so it's going to be times 100. Your answer should be in the form of 100. Okay, so percentage yield formula is what? Actual yield over theoretical yield times what? 100. So percentage yield will now be equal to what's my actual yield, everybody? Actual yield is that mass of that compound given in the question, and they gave us 122.5. It's simple to get. You will see it very, very clear, so lucid. Okay, so it's actually 122.5 grams divided by theoretical yield, the mass of that same substance you calculated for. This is your own mass, over 180 grams, 0.24 grams, 180.24 grams. So know that you are actually working in the right track. Your theoretical yield is always higher than your actual yield. Note this. Theoretical yield is always what? Higher than the actual yield. So it's going to be times 100. Okay? The theoretical yield, the one you calculate for, is always higher than what they will give you in the question. So 122.5 divided by 180.24 times 100, that's 67.965%. So we're having like 67.965%. This is your percentage yield in this particular practice question. Is actually very easy. So guys, we've come to the end of this video lesson on stoichiometry of limiting and excess reagent. If you find this video lesson helpful, make sure you click on the subscribe button to this channel, share these lessons with your friends, like this video, very important. And also, I'm going to give you your own practice question soon, so you solve and provide the answer in the comment section. Okay guys, here is your own practice question, so you solve and provide the answer in the comment section. It's actually very easy. Please, as you are solving, solve carefully. You don't have to rush, okay? Make sure you solve and provide the answer in the comment section. If you check the first practice question, it's not on you trying to determine which is limiting on excess. It's a straightforward question because they said when 25 grams of HI, hydrogen iodide, here is it, are treated with excess of H2SO4. Remember, whenever you hear excess of something, you know that excess. Okay, let me not be explaining how to solve the question. Okay, let me not say much. Let me just pause here. 20.5 grams of I2 are obtained. So they obtain this. The reaction is this. Calculate the theoretical yield and percentage yield. So definitely you already know what you are looking for. You are looking for the theoretical yield. Theoretical yield is you getting the mass of this same compound given. They gave you the mass, the one they got, according to them doing the practical and everything, because these things are practical questions. So you now solve it, calculate it, because theoretical yield is like calculated yield. Solve for this guy based on the parameter given to you. And this is straightforward. They gave you for hydrogen iodide and you're looking for this. Simple. Remember, I told you stoichiometry is all about two relationships. This and this, relate them and get your answer without stress, and then get your percentage yield. The formula is actual yield over theoretical yield. Get your answer. It's not difficult, actually easy. Well, for question number 2, this is where you have to apply the concept of you knowing which is limiting and excess. I don't want to say much here. You can actually solve it. And if you find my video lessons helpful, not just this, all of my video lessons, make sure you click on the subscribe button and also share these lessons with your friends. Thanks for watching.